Okay, so in this video here I'm going to be talking about some helixes and conical spirals that we'll see throughout dynamic mechanisms. So the first way I'm going to talk about is the helix, and that's going to be the development of a cylinder with a straight line going from the bottom to the top will produce a helix in elevation. So as you can see here, we have a development of the cylinder, so we find that by taking the distances here and we can mark them off across 12 times for each split up, and then we can draw a line here from the top to the bottom, and that would produce a helical spiral as we see here. This would be a right hand helix, and we can also see a left hand helix down here. See, it's going the other way, counterclockwise instead of clockwise. Similarly to this, to find a helix on the edge of a cylinder, we can use the split the line method. So I have split this line here into 18, and this will make the path do a 1.5 revolutions going up. So as you can see, it's going starting here, going up 1 revolution and then a half. That's because it's the circle is split into 12 and the line is split into 18, so that's going to be 1.5, or 18 over 12, sorry, 18 over 12, and that would be 1.5 revolutions. 1.5 revolutions. There. So following on from this, on the helix, so as you can see, we can find it from the development, and by splitting the line, both of these methods work because we're taking these as heights along. So each of these are corresponding heights of this next one along. So this first point here at the bottom, this bottom line, the next one then moves up to the next line, third one, and so along. They're still wrapping around the edge of the cylinder, so that creates a helix. The other ones that we might come across here, creating screws from helix. So as you know, you can see down here in plan, we have a internal and outside cylinders. So you can see that it's going to create this path here up along it. So you can see the kind of screw that it's going to create. So we have the pitch, the lead, and this would be the thickness of the screw depth here. So we're using the split the line method here. Outside of helixes, we can also see that we'll come across conical spirals in this topic, and there are two main types. We have the Archimedes and logarithmic spirals. They both follow the same kind of principles along here. This time we're moving around a cone instead of a cylinder. That's for the conical spirals. So the Archimedes spirals are just increasing the same distance again and again, and then the circle is split up again, and you can see the spiral it creates here. The logarithmic, on the other hand, follows a set rules. So you can see here that it's getting bigger, 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 and bigger again. So this is following a rule of it's doubling every time. You can see the spiral it creates along the edge here. Similarly over here, you can see the spiral that it's going to create. So these are the kind of special curves you'll incorporate within dynamic mechanisms. So from creating a screw, helix, double helix, knowing the difference between left and right hand helixes, and drawing logarithmic and Archimedean spirals. Thank you. This is about the spirals. Thanks.